Before you start your research project, think about how you will eventually code your data, because data coding happens to be the key to quantitative research. Visualize your final data in a spreadsheet. In other words, think of Microsoft, LibreOffice, or Google Sheets. And if you cannot figure out how to put your data into the rows and columns of a spreadsheet, then you have not properly conceptualized your research. This is what your final data should look like. You have your subjects in the individual rows, and the columns represent different variables. Each number that you see here represents the score of a given subject on a particular variable. There are two important rules for this coding. The first rule is one subject per row and one row per subject. In other words, all of a person's data belong in that same row, and no one else's data belong in that row. Notice here that this row has all of our first subject's data. A yes-no answer, dummy coded for variable x, a rating on a 1 to 5 scale on variable y, and another score 0 to 100 on variable z. All of these data come from our first subject, so all of these data are in row number 1. Now there's an exception for Rule 1. When doing a matched pair design, the row represents the pair, not the individual person. Suppose we are researching married couples. Here you see data on 5 different married couples. In other words, a total of 10 spouses. The first variable, dummy coded, is did the couple have a church wedding? No, no, yes, yes, no. The second variable on a 1 to 5 scale is the husband's satisfaction with the marriage. The second variable that we see over here is the wife's satisfaction with that marriage. Another exception comes to Rule 1 when your sampling unit is that of institutions or time periods. In this case, each of those will get its own particular row. Here we see each of our data units is a different public school in the Redlands area. This column represents average reading scores, this column is average math scores, and this column is average science scores. Here we see that each row represents a different year, and the numbers over here represent the average scores for that particular year. Rule 2 says we should have one variable per column and one column per variable. Now there is an exception. When dealing with a variable that has multiple nominal scaling, and if you want to use a correlation matrix instead of an analysis of variance, what you should do is make each category within the multiple nominal variable a separate column. In other words, a yes-no variable of its own that we can dummy code. For example, suppose one of our variables is which university a student attends. Is it UCR, UCI, or UCLA? Now that's actually a multiple nominal scale. A student would not be attending more than one of these. And so we would arrange it like this. Is the student attending UCR? Well, number 1 is not, so code that as a 0. He's not attending UCI, so code that as a 0. He goes to UCLA, so code that as a 1. Now you can have a situation where you can do without a spreadsheet, but those situations are pretty rare. For example, if you just have one variable and your design is a sample versus norms design. In that case, just count up the individual numbers of subjects fitting in each category, and you compare those with the norms later. Another exception is when you have two variables, and each one of those two is measured in a binary nominal scale. You're eventually going to look at a 2 by 2 contingencies table something like this. Your rows will represent the grouping variable. Your column will represent the criterion variable, such as whether or not the subject passed a performance test. Now, as we come to our individual subjects, we can just mark them as they come in terms of which of the 4 cells the individual falls into. Let's suppose our first observed case is in the first group, and that person passed the test. So we make a mark right here in this cell. Our second person was also in group 1, also passed the test, so we make a second mark. Our next subject was in the second group and failed the test, so we make a mark down here. We continue until all of our sample has been recorded, each person in one and only one of these 4 cells. Suppose we end up with 9 people in the first group who passed, nobody failed. That's a total of 9 people in the first group. In the second group, we had 3 who passed, 11 who failed, for a total of 14. So we fill in the other totals, a total of 9 subjects passed, or rather 12 subjects passed, 11 subjects failed, for a sample size of 23. But in general, think of the spreadsheet. And if you cannot figure out how to put your data into the rows and columns of a spreadsheet, then you have not properly conceptualized your research.